Oh, did that not work? Okay, let me try again. Hello. I feel like the audio was broken. No, I'm looking at this bar here, and it says quite obviously that's going to the green. And going into the green on OBS isn't good. It means that no one can hear you. And going into the red means that you're blowing people's eardrums out. So you should be in the yellow. But when I go, hello, I'm using like my full voice here and it's fading away into the green. Outrageous is what it is. Right. Okay. Hello, everybody. Thumbnail's a bit different. It is because I have made a realization, right? With these past few thumbnails and these past few videos in general, I've been fucking lying to myself. Because what they present is a person with considerable self-discipline, consistency. Because, you know, normal people, they go up and open OneNote and then draw little sketches and then use those as their thumbnails. But what I am in reality is a very chaotic person. Everyone who's ever met me says this. Chaos. Chaos is kind of the definition. And when I'm streaming to tens of thousands of people eventually, I'm not going to be the perfect model student. Because being the perfect model student is really boring to watch. So you know what? I'm lazy and lie. I'm gonna fuck some shit up, right? We are gonna be doing STEP again. You want to know what STEP is? It's sixth form examination papers, I think. What does T stand for? Fuck if I know. The point is, they're hard exams, they're hard math, and I'm gonna do it. And also, you'll notice the outer half of the thumbnail says C. The C programming language is the most beautiful thing constructed on this planet Earth. That's why we're going to learn it, because C is how all the other languages get made, anyways. So it's like if you learn C, then you basically know every other programming language, right? Because the other ones, they're all basically C. So you could all rewrite them in C, anyways. Except like maybe Lisp before trying like the shitty irrelevant ones. But those are shitty and irrelevant, and therefore we're not doing those. Not right now. We are going to be learning scheme later, though. But that not relevant right now. Anyways, so we're continuing on from last time. Last time it was bad because I had a mental breakdown over my pen no longer working. So this is what's going to happen. Our pen only works when my computer is not plugged in. If it is plugged in, it will immediately break. And a bunch of other stuff breaks too, but it's not that relevant. So, our solution. Right now, I am on around 40% charge. I'm gonna do my math until I get to 5% charge. At which point, we're gonna transition into C programming. Yep, that is literally the plan. We are going to transition into C programming, do that until we charge up to 100%, which is going to take forever, and then unplug, go back to C program, not C programming, but go back to step programming, step math. That is the plan. It is then stopgap measure, really shitty, only something that a moron could come up with, but it's what we gotta do until my drawing pad thingy arrives. Which, by the way, did you know those can also be used to play Ostu? Unrelated, we might be doing gaming streams in the future. So, without further ado, let's go fuck up some shit. So, we were on assignment 3. Yeah. So, last time I was really struggling. I mean, I was struggling on this question. It took me forever to figure out. This is just a geometric series when r equals 1. So, yeah, let's go ahead and do question 3. Or part 3 at least, because that sounds way more interesting. So what this is a geometric series. So yeah, it's a geometric series, and also this is wrong because this doesn't have a in it for some reason. But no matter. Oh, it's because this doesn't have a in it. Like the original one doesn't have a in it, and that's why it doesn't have a. But I digress. Let's go and do part 3, A. Right? Okay. Let's just write out the geometric series formula, which we just did. Lovely. So we have set our thing up, and now we've got to compute it. 2 to the power of 9 should be 512. Every computer scientist has this memorized. It's just one of the things we've got in our toolbox. So now it looks like this. Multiply this by 2 becomes this. By the way, we are using NCS Music today, because NCS Music has no copyright on it. And to be honest, I didn't know what the hell I was playing before, but it certainly was not stuff that I listened to on the regular. Whereas this, I've actually listened to before on multiple occasions, those being my entire childhood. So hopefully, it should be more familiar with everyone else. Also, I noticed that I keep saying so, which is why every time I say so, we are going to make a little note of it, just because I think it's really funny. Sketch the graph. Question 2, sketch a graph of y equals 2x plus 1, which is very easy. Let's do this. This being 1. Now, we need to compute an integral looking kind of like this. This is 2, this is 5. I'm gonna erase the y-intercept because it doesn't mean anything here. We can work out this is 5, this is 11, and therefore area of the trapezium, 3 plus 6 divided by 2, multiplied by the height, which is 3, and that equals 27 divided by 2, which is correct. Oh, this is I. Not so. Part 2! The square bracket floor notation means the greatest integer less than or equal to x. What are the integer values of certain values? It is 10. It is 8, because square root of 70 is bigger than square root of 64, which is just 8, which is again, square root of 70 is smaller than 81 square root. So therefore, it is 8 point something something, which is just 8. 6 is 6. 10 pi, 31. Dot, dot, dot. It's free. For a fairly obvious reason. It looks something like this, where this is 1, this is 2, this is 3, this is 4. That's part 3. This isn't difficult. You should be able to work this out if you have experience with the fourth function, because if you consider the graph, 0.5, that's just going to go down to 0. And then 1.5, that's going to go down to 0. 1.99999, that's still going to go down to just 1. So yeah. Soviet Union, we love communism. If only it worked. Use your sketch in part 3 to evaluate this number, which is simply going to be 1 times 1 plus 1 times 2 plus 1 times 3, which is, of course, 6. IV. Finally, V, which is so close to our step question, our lovely, lovely step question. Let's try and do this before we hit the terrible mark where we have to switch to C programming. C programming. Outrageous. Sketch a wonderful graph. 2, 3 of x times the floor. So it's just going to be 0 until here. It jumps up to here and goes like this. Because if you think about a normal x graph, it's just going to be like this. And if you compare it to this, the graph we drew in III, This is 0. So from 0 to 1, it's just going to be 0. From 1 to 2, it's going to be 1. So it continues as normal. Then at 2 to 3, it doubles. Oh, it doubles because now the multiplier is 2. And now we've got this graph. Now we may very simply evaluate this as 1. This is going to be double the rate. No, actually, it's just going to be the normal rate because the multiplier is just 1, so it's going to be 2. This is, however, is going to be 4 because it's double the rate because it's multiplied by 2. Anyways, let's continue. So it's going to be another application of the trapezium if we just split it like this. So 1 plus 2 divided by 2 multiplied by 1 plus multiplied by 1 divided by 2, 2 plus 4. So it's actually just 3 plus this, which is 9. Divided by 2, of course. So now, finally, the step question. The step question, the square bracket notation means the greatest integer less than or equal to x. For example, pi is 3, and yeah, we've already experienced this. So we now sketch a graph. Oh, this is a question that we should have seen in the TMUA before if you've got experience. But if you don't, trivial indeed. Trivial, just like everything I do. It is... Okay, this is not trivial. Okay, this is 0. This is y, this is x. I like to do this for all the fancy graphs I need to draw. Like the simple graphs, you can just skip it, but for fancy graphs, it's better than nothing, right? So this is still going to be 0. This is going to be 1. But this is going to be square root of 2. This is going to be square root of 3. This is just going to be 2, and so on and so forth. Because first you apply the floor, and then you square root it. So actually, we I also need to put the same rule on and and the other filler noises that I tend to make, but those can come later. And also maybe but, and also maybe then. Maybe even and. That would be fun. A stream without and, then any connective whatsoever is illegal. We're programmers, right? We're mathematicians and programmers. We don't deal with these silly little English expressions. That's also why I'm taking the SAT in August and I'm going to get 2 on the reading and writing section. Speaking of, did you guys know that, what's the thing? Completely forgot what I was going to say. Right! They've added geometry questions. They've added a great load of geometry questions and also complicated reading and writing questions to Module 2, which is the harder one. Not good for me. Those are not my particular strengths. My strengths are the easy questions, which are most of them. I prefer that they add more easy questions so I can get a 1600 and then not have to work anymore. But we will see how it goes when we start preparing for it, which I may or may not do on stream. College Board is linked to my in real life name and my location and my bank account details and others, which may not be great to leak on the internet. However, I might create a second account. I don't know if that's possible, but another. Oh, I keep repeating but. However, may chance we shall see. Anyways, let's go back to the graph we're sketching, which is this lovely graph, which we've already sketched. So this goes on for infinity. So these are our rectangles, so we can model them pretty easily. And it is plainly obvious to see that by adding together these rectangles, it does become some kind of sigma notation. So actually, let's just write this out. Multiplying by the width is just always going to be 1, multiplied by 1, multiplied by 1. And this is always going to be the square root of this number. Yeah, so here is 0, so that never counts. 1, 2, 3, and so forth, until you reach the lovely a minus 1 times 1, which we can pretty easily sum up as a minus 1 or equals 0 square root, which just so happens to be our answer. So that was the easy part. Now let's go do the hard part. Show that our lovely integral here is always 2 to the power of a minus 1. So again, we are positively assisted here by drawing a lovely graph. It starts out at 1 always, because 2 power 0 is 1, 2 to 1 is 2, so it doubles here. And then here it goes on to become 4, here it becomes 4, there it becomes 8, and so on and so forth. And these are always just going to be width of 1. So, and we can do the same process this time. It's just going to be times 1, times 2, times 3. Oh, no, actually. Oh, I've drawn this, I've written this completely wrong. So, it's also going to be adding together the rectangles. I keep repeating so and but. I need to find other connectives. I don't know how other streamers do it. Maybe I should watch some other streamers. I also say maybe a lot. That is the critical flaw. 1 times 1 plus 2 times 1 plus 4 times 1 up until our limit, which is 2a a. Is it just a? No, it's not. It's a minus 1, isn't it? That does not appropriate. Times 1. So this becomes effectively 1 plus 2 plus 4 plus 2. 2 minus a. Which is pretty easy to turn into another lovely expression. Such. Okay, so from simple inspection, you can deduce that this is probably going to be 2 to the power of a minus 1. And the way we can prove this, I'm thinking, is that we can do this inductively. We need to show that 2 a is equals to 2 a 2 to the power of a minus 1 plus 2 to the a minus 2 plus and so forth, right? I'm not quite sure how to do this. Fucking hell. I mean, it's plainly fucking obvious, isn't it? If you just think about like squares and shit. Like, this is gonna be equals to half, plus 1, and then also plus 1. Then you can just extrapolate that for like 8, right? It's gonna be 4, 2, 1, and then you're just missing 1, and so on and so forth. So, we know it's true. It's just, how do you fucking prove it mathematically? How do we prove this mass is equal to this mass? Okay, let's go read the discussion. This is very typical of STEP. The question involves a function that is unfamiliar to you, but which is defined more carefully, so you then use the function for difficult tasks. There are different concepts. Clear diagrams are invaluable. Right. This isn't that hard to prove. This is really is not that fucking hard to prove. I just don't do proofs that much. Again, programmer, hello. Fucking A. It'd be useful, I'm just saying, if there was a chat that I could copy the answers off of. But due to my own okay, come on. Due to my come on. I'm trying okay, you can't see this on screen, but I'm trying to click something right now and it's not working. Oh hey, Spectrum. Shine into it is no use. Stop it from shining through. It's true. Okay, I've opened this up now. Right. Okay. So yeah, still no viewers. That's fine. I don't particularly mind. Right. Opening up back the question, how do you prove this? Oh wait, okay, so let's do this. So k equals 1, right? So should know a equals 1. B minus 1 equals it's just 1. Okay. So yeah, we were assuming that it's k minus 1. Yeah, that is obviously true. So yeah, now we've proved it by induction. So now what? So yeah, induction proof that was it? Therefore, this equals 2a minus 1. Yay, we did it! Even though I'm pretty sure that was using illegal techniques that we shouldn't have had. Yay! Maybe they'll teach us induction by proof in the future, and then we can come back to this and we can retry it. Or maybe I'll just look at the answers and then try. Oh, so that's what it meant by we need to use the floor function again. So, okay, we've already drawn this lovely graph. We're just gonna copy it. I don't care enough. Whoop. Yeah, could I copy? Paste. Yay, there we go. So now we've got this lovely graph. So now it's saying that a is positive, but it's not an integer, and we need to figure out how to do something with that. Which is going to require, of course, a bit of a floor function, which is not ideal. Ooh, that's clever. Okay, so we can decompose this question into two parts. Essentially, the first part is I am sorry for not speaking too much. I've just been in thought, but we are going to start speaking more now. So we can decompose this question into two parts. One part we've already done. One part is just evaluate all of the whole integer bits, and the second part is evaluating the part where a is split. For example, if it's 3.5, no, actually 2.5. Forget that 1 sec. If it's 2.5, then it's 2. You've got this bit, and you've got 1.5, 0.5, which is this bit. So we can split this. How do we split this? Well, we've got a 2 that allows us to split it already. It's the floor function. So what we do here is first we write 2 floor a minus 1. And that's this bit again. So that's this bit already done for us. And then we've got the second bit, which is the part where it's split. So how do we find out what the integer bit is? It's just going to be a minus 4a, right? That's going to be the length, the width of this triangle, which, yeah. So now that we've got that, we can then just multiply it by the highest possible number that we've got here, which happens to always be, I think, 2a square root, no, floor minus 1. Actually, we should be using the ceiling function, shouldn't we? Yeah, actually, the minus 1 isn't necessary. So yeah, now we've got this, which I'm pretty sure could be simplified further, but I don't care. So now we've got that, which should deliver for us the correct answer. We did it! Only mild amounts of suffering needed. Now let's go do the warm down. How much battery do we still have? Plenty. 21%. Lovely. The warm down is Arthur. Okay, A, B, and C. Together with an orangutan, are shipwrecked on a desert island. Terrible. They spent the first day gathering a total of 8 bananas, which they heap up into one pile. Then they go to sleep for the night. In the middle of the night, Arthur wakes up. He decides to take a share of the bananas. Oh no, I recognize this. I recognize this from the closer book of mathematics. It's that fucking question, which I don't remember the solution to. He decides to take a share of the bananas in case there's an argument about it in the morning. Divides it into 3 piles, and then gives the banana over to the orangutan. Yeah, okay. He divides the bananas into 3 equal piles, takes the leftover banana, gives it to the orangutan, hides his pile, keeps the rest together, goes back to sleep. Brendan wakes up, does the same thing. She has one leftover, gives to the orangutan. C does the same thing. In the morning, the 3 of them divide the remaining bananas, which come up in 3 equal shares of M bananas, with one left over for the orangutan. Of course, each one knows that there are bananas missing, but each one is as guilty as the other, so no one says that. So, N is the total number of bananas. Useful to know. N total. M is the equal share. So, now we can write out some equations, which I am fortunately very familiar with. 3a plus 1. So yeah, the first one is takes all the bananas, divides them into 3 piles, puts the leftover one, gives it to the orangutan, and then so on and so forth. And then the pile that remains is actually 2a because one of the piles is hidden and one of the bananas is given to the orangutan. So it's 2a, which then equals 3b plus 1. According to the same logic, it's also 2c. Nope. It's 2b equals 3c plus 1. And then 3c equals 3m plus 1. Wait, no, it is the same logic, so it's like this. So now, annoyingly enough, we have to do a lot of manual labor. First of all, 3m plus 1 divide by 2 is equals to c, which means that it is 3m plus 1 divided by 2 plus 1 divided by 2 is equals to b, which we can compute to make it a bit less, obviously terrible. Make it 4 divided by... No, it's not actually 4. It's 2. Yeah. So that's b. Manipulating this, we can then see that 2a is equals to the same thing, right? We're just doing the same process again, multiplying the entire thing by 3 plus 1. I feel like I've done something wrong here. Yep, I can confirm. This is actually 9. And then we're dividing the entire thing again. Good lord. Fun and interesting question, am I right, guys? I picked this question to do myself. I don't know. I mean, I didn't pick it, but I picked Step Foundation to do instead of actual TMU questions. But the thing about actual TMU questions is that they aren't as suitable for, saying out loud, so... Now we are we're multiplying by 3 again. Oh, wait, are we? No, we don't have to divide by 2. Okay, so now it's n. Finally, we've reached n. Which is 9 times 3, 27, 3m plus 1, 8 plus 18. Yep, lovely. Now we can times this entire thing by 8. 81 times m plus 27 plus 8 plus... Yeah, so basically we multiply the entire thing by 8. And then all is left is to deal with the leftovers. Yeah, so there's nothing all that smart about this. It's just math. Yes, so now we've finally dealt with this epic mess, right? Now we have to show that if n satisfies this number, then n plus 81 also satisfies this number. Oh wait, we have to show that if n satisfies this, n plus 81 also satisfies this. Ah yeah, negative bananas is how you solve it for part 3, but still, part 2. Okay, so reading the tips, right? It is essentially asking us, let's find some new integer m dash, which satisfies this for n plus 81. Should be obvious. Yeah, this should be obvious. I don't know how it's obvious, but it should be obvious. Let's see. Okay, so n dash equals n plus 81. I feel like fatigue is a main part of how these step questions become very difficult. So doing this long stream is definitely going to help that fatigue. Because usually I get really tuckered out after like an hour or so, and then I just give up, which is what happened with all 8 of my previous streams. But this one, we're going for 8 hours straight. Dinner is going to come in 2 hours ish. We're going to quickly finish that. Then we go on to continue with our step expedition. So let's see if n satisfies. Okay, let's see. So n plus 81 equals 81. Surely it's just 81 n plus 1 plus 65, right? Because if you're adding 81, then all you need to do to get rid of the 81 is plus 1 to m. Then they will add 81 to the right side, and then they'll cancel each other out, becoming 81m plus 65, which we already know is true. So that settles it. Finally, the third part. And it is again trivial to show this, I hope. Two, three, seven. Okay, so negative integers is part of the solution to part 3. I just don't remember how. Oh, because I've already written it wrong. stupid spot that I am not very good at math. Or at least not very good at substitutions. It's not very good with like arithmetic, okay? Frequently stumble. It's basic arithmetic. Wait, again, I keep doing this wrong. This is 8 times -2 plus 65, which means negative 65. 65, yeah. This is negative 16. 1, which means that m is -1. God damn it. Yeah, and then we can say that n plus 81 also satisfies. So so n equals 79 also satisfies. And if someone pulls out a calculator, not me, I'm too lazy, then we can figure out that this also works. Yeah, if you have time, you might like to find a general formula for the integers n and m that can satisfy our clause. I don't know if that can satisfy an asterisk. I'm not sure how you refer to the good old thing. So yeah, we need to find a way. Oh, so we need to find a way to satisfy. How do we show that there are no others? I don't usually talk for this long. I just don't have the stamina to do it, I guess. Look, stamina is something that can be trained, right? Stamina in all kinds of ways. Physical stamina, mental stamina. It's just talking stamina. It's just another type of stamina. Keeping in mind that I don't have many types of stamina, just overall stamina. It may be difficult, but we can persevere. Ooh. If I had to stream for 8 hours, I won't be able to shower. That's one. It's kind of a. It's an issue, isn't it? Oh well, showering is kind of optional anyways. I'll shower at like 3, yeah. What's the worst that could happen? So let's continue. If we have time, which we do, let's find the general formula for n. And m, you can satisfy. Now, how do you find a general formula? Because we already know the numbers are this, 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 and so on and so forth. How do we show that there are no other solutions to this? Let's write this as 5b. Show only n2 plus n solution to n. How do we show that only this is the solution to x? We sub this in, like just a stupid fuck. What do we sub this in? That's fun, but that doesn't help us. much like many things in life, such as drugs and gambling. Fun, but does not help us. I really need to keep clean my screen. It's like got all kinds of junk over it. Gunk, not junk. I would notice if there was literal garbage on my computer, I assure you. Takes one to know one, I guess. Okay, wait, focusing on a question, which we need to do, by the way. I can't like zoom off on an ADHD rant, during, more for the words, during a Cambridge computer science interview. I've got to lock in. Show that n equals this solution. There exists some integer n such that this is valid. How do you show it? How do you show it? Come on. I'm not quite sure. How do you show that there are no other solutions? I'm not giving up on this, by the way, unless I run out of battery, in which case I'm kind of forced to. I have 8% until I reach 5%. So I have 13% total. If I reach 5%, then I'll quit. So that means I have 8%, which is like 10 minutes maybe. So there's not a lot of time, we'll say. Not a lot of time. We need to find a general formula. Oh, this is hard. I'm not even sure where to begin. Like, we've substituted this in, which has produced this 8n equals n plus 1. And so for any value of n, this will pretty much produce a value of n that is an integer, which is great. Greatness for us. But it doesn't help. It doesn't help us show that the others don't exist. Maybe we could do contradiction, proof by contradiction. Okay, so what are we doing again? Okay, so assume some solution not inform this as for asterisk. Actually, no, we don't need to do that. We've already figured out the solution, I think. No, we don't need this. We don't need any of this garbage. Oh, delete the rest of the garbage. Because we've already got this. For any value of n, actually, yeah, we could just say this is k, right? So, k, there is. Actually, no, but what if. No, this doesn't. This doesn't disprove the fact that there are solutions outside of it. So we know that any what? You've run out of you've run out. The undo stack unfortunately is quite limited, so we won't be able to restore it. But basically, the flaw with this reasoning is that you have proved that for any value for any integer, you can plug it into this and then get a valid solution to asterisk. But we've not proved that no solutions exist outside of this. So how do you do it? Again, you could assume is what was it? 81n minus 2. So now that we've assumed there is a solution not in that, what do we do with that? How do we start? What's the thing that we base it off of that we can manipulate? I don't know. I'm not willing to give up on this, but I am genuinely quite stuck. Show that there are no other solutions. Don't think proof of contradiction would be the start of a solution to this, because I can't think of a single one. If, stupidly enough, what if we put no. You could go proof by case. Now this is really dumb. You could go proof by case and prove that all of the integers from -2 to 81 don't satisfy. That's for obvious reasons not feasible. Wait, I've got a thought. Okay, I've got a thought, right? We assume to be invalid m equals ab where A and B are co-prime. And B is the B is not 1. So that means that it has to be a fraction. Yeah. So actually no, that's not an assumption, that's just truth. For M to be okay, we'll manipulate a bit just to make it look nicer. Yep. So then some K M equals yeah, okay, no, this is good. So now that we've got this, must be OT code of 81. The thing is since you can write this in any number of forms. You can write this in like 80, 81, 81 and minus 2, or you can write it as 83, 81, and which these are basically the same thing since n is arbitrary, but like how do you prove that it has to be in that form? which means that, okay, what if we just say n must be? I don't know. I genuinely don't know. I don't have the mathematical tools to do this, maybe. Assume that there is not a solution. Assume that there is a solution, not in that form. But no. You know what? The reason I started the 8-hour stream was so that I could prove to myself, and I'm running out of battery. I have to give up. Fuck! Okay. So that lasted no fucking time. I was about to make my inspirational speech. Then I got interrupted by myself running out of battery. So we are going to have to switch to C, unfortunately. So let me put this up. Coding as a blank fucking window. Right. I love blank fucking windows. Wait, no, I can actually do book. This is step. This is book. Okay, give me a second. Let me fuck up my bit. So this should be Visual Code Studio. By the way, I need to turn off the agent and also this. Yeah. Okay. And this Firefox should not be Firefox. Well, it should be Firefox, but it should be another Firefox method. How about I delete this? Copy this. Name this coding. Yes, works. Okay. Okay. And this be one. Oh, that's the wrong one. Okay. Wait. How do I do this? This one note. This is book. This is step. This is all kinds of fucked. Wait. Oh, Lord. This is all kinds of fucked. Okay. Give me a second. Let me figure this out. Right, this is perfect. So I'm just gonna delete this. I don't care enough. So, duplicate this. We got this step. Okay, whatever, good enough. Okay, so this is code. Then this is this. Yes, okay, finally. This should work. Oh, and I fucking fucked it up. Okay. Wait. Wait, why are these all the same? That's not good. Oh, because they all use the same source. Like the exact same source. Okay, so this is the S code. No. That's not it. Okay. Is this still No copyright. This don't sound like copyright. This sounds suspiciously not copyright. This is not copyright. But this. I appreciate that I am on screen right now, but this you can consider this a bit of fun. Consider it a bit fun. Oh, I messed. Oh Lord, I did. Okay, so nope, still wrong button. Okay, there we go. This is still wrong. For some reason this is like really small. Oh, it's because it's this. Okay. See, this is better. Huh. This should be perfect. Okay, so now we've got coding done. Now let's go and rearrange OneNote. See if this works for us. So no. Oh, works great. Lovely stuff. Lovely. Okay, this works. So now I've got book, step coding, and then break. Okay, so now let's go take a break. I need to drink water. I need presumably a walk outside after that enraging experience. And it's been an hour, so I guess, it's about time anyways. How do I edit this? This is an image. I can't edit it. I can put the text here. Which Yep. Okay, done. Right, hello, I have returned. Why is cat paying output? How do I fix? Is fix? No? No. Okay, it's not fixed. Let's see. Okay. Battling loop. Okay, there we go. Save. I have to save it. Right. Nah. Okay, there we go. So, now we're doing some coding until we charge ourselves back up. So now we're on 17%, which is a decent amount. Let's see if we can find some better music, though. Is the Fat Rat copyright free? Free to use and monetize. You include fruit track record. Oh, yeah, that sounds like a pain. I'm not gonna play Fat Rat music then. I'm a pretty big Temnite fan. Let's pull up some Temnite music. Temnite DMC free. Wait, we could just look up Seal DMC free? Wait, actually. Video copyright. Is that nothing? Does he not have like a list of songs that can be used? Well, I guess this is DMCA free, so we'll just shuffle. Anyways, okay, so ignoring the ghetto touring. Let's go to OBS, we're coding right now. So we need another window capture coding. Oh, that's big. Let's see, does this work? No. This is good. Yeah, okay. So, what the hell is this? There we go. Okay, so Modern C, the programming language book for consultants. So, let's start from the beginning, right? I have read through quite a bit of this, and so I'm going to skip through some of the major concepts. For example, C. Let's see. Let's see here. So, takeaway number one, right? Don't panic. Oh, great, we won't panic. Takeaway number one, C is an imperative programming language. Imperative means that I think the definition is that it goes from one line to the other. It's basically like sequential. Is that what imperative means? Is that what the definition of imperative is? Yeah, so it gives it explicit step-by-step commands on how to reach goal. So, a C program is this. This is the first very example of a C program that presented to us. So, first line is imports libraries. Second line is main, the main function that you put everything into with some random arguments that aren't never used. So, funnily enough, the version of C this uses is, I think, a little outdated, so we're just gonna not have that. Hopefully, it doesn't cause any problems in the future. I say this if it's obviously foreshadowing. It declares an array, which is A, and gives it a bunch of values. They're all doubles, and then does some work with them with a for loop that simply prints out AI. Ooh, AI. This is for artificial intelligences. And AI times AI. So people who use Python know I is just going to be our like iterating variable. So it's just going to be 1, 2, 1, 2, 3, 4, and so forth. This is just accessing the array that we've had. So it's going to be 9, 2.9, and then so on and so forth. This is just going to be its times itself. Now, the funny thing that they've given us here is this ugly block, which really should have been my first warning sign. See, modern C isn't like other programming languages. Modern C, for some reasons, thinks that you already know C, and I think it approaches it from the perspective of when you already know C, which is why you'll see later on, some of the challenges it provides are ridiculous. It's outrageous. Like, how are you supposed to do this? You've barely introduced anything. But I digress, right? Element, I think this is a space, and then percentage sign ZU, percentage sign G, percentage sign G. I think percentage ZU is supposed to be a format specifier, which is the thing. So it replaces so the first format specifier replaces like the percentage ZU with the first argument that's provided after it. And then G is for doubles and ZU is for integers. And yeah, so the order of it matters. So ZU, GG, so it'll go integer, double, double. And I think that's how it works. And then it returns exit success. Yeah. And then, this book, so the first thing I said is that it's really difficult and it does not attempt to present things in order. The second thing is that it outrageously just shoves all the jargon in your face. It would shove, like you can see here, this is what, like the fucking second page? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 pieces of jargon on the same page, which it barely attempts to like describe to you at all. Like some of these are obvious. Print is just print. Statement is statement. But then it just a call, function, arguments, parentheses, string literals. Like, yeah, and it does specify what a format specifier is here, which is how I learned about it. But at the same time, you can stand to slow it down. Come on, like compare that to something that actually teaches you C, like learning C. Like I'm sure there's a programming language that learnc.org. This has to be more sensible, right? Like, look at this. This is like, hello world. What's a variable? What's an array? What's a multi-dimensional array? What's a condition? What's a string? So on and so forth. Like a reasonable step-by-step tutorial. Whereas this shoves it in your face. Expects you to know it. Outrageous. Outrageous. Also, it doesn't get better. Trust me, it is not. So takeaway at 1.2. C is a compiled programming language, which is lovely. So for those who actually don't know, we have generated this exe file here. So what you do is the C compiler, when you press run, the C compiler turns the C file into an exe and then runs the exe. So that's how it works. So it generates a new exe file every single time. It's called an executable. So it is compiled. And a correct C program is compatible between different platforms, which is wonderful. And then it goes on and on about some other stuff about like platform dependencies and writing correct C programs and whatnot. And then here it goes on a little more about how to execute a program, which fortunately we don't have to worry about because we can just click this one run button, which causes it to run. So we go on and so forth. C program with flaws, right? So this breaks because they're using like different compilers. So there are different compilers, there are different implementations of the same C standard, which cause problems. Yeah. So the differences between this code and this code caused an explosion. And then it goes on about how Clang and GCC are different. Which one are we using right now? I was sure that we were using one of them, like previously, but how do you check? Like run, maybe? How do you control Shift R? Yeah, it doesn't work. Let's see. Run? Does that help? Not really. Okay. VS Code, how to check which C compiler we are. Okay, C compiler. Config. Oh, I just realized. Have I just broken my... Oh, I was on the wrong page the entire time. Okay. Yeah, this is a problem. This is gonna be a problem at the very least. Whatever. This is working. I don't think it is. Anyways, okay. Yeah. Oh no, it is working. Okay, so I had to check my YouTube stream to make sure it was displaying this bit. Okay, it is. So, let's go into settings, which is here somewhere. Preferences, settings. I just want to check where the compiler is. I just want to check what compiler is. Let me just go back to Google. Oh, chat tasks. Yeah, lovely. So, oh, here, GCC. So we're using GCC. I forgot what the difference between the compilers was, but I'm sure it's irrelevant. So let's go back to programming. Having these all tab a lot more than I should. So, Clang is more picky than GCC, gives us okay. We're just okay. A C program should compile cleanly without warnings, which is something that we're gonna ignore. C, grammar. So, we use the following keywords or special words that represent concepts that cannot be changed. There are 6 types of brackets, which of course we should all just tell me that immediately at the start, right? That's great. There are two different separators or terminators, comma and semicolon. Comma separate arguments. Commas can follow the last element of a list of elements. Great. Punctuation characters can be used for different purposes. Okay, so, oh wow, I forgot how terrible this was. So, comments are done by this or double slash. I think double slash. Yeah, double slash also works. So, that's how you do comments. Literals are items which refer to fixed parts, fixed values which are part of the program, like 0 and 1 and 2, and doubles and strings and so forth. And these are literals. Identifiers are names for certain bits, like the data object is named as A or I. Type aliases specify the kind of new object that is used. So, this is useful. So, underscore T means that it refers to type. So there's functions and there's constants, and these also have names. Functions. So main and printf are functions. They are defined. Their declaration is followed by function body, which describes what it's supposed to do. Definition goes from line 6 to 24. So yeah, this is in fact our definition. Function body. This is the function body. Wait, no, is this the definition? Like line 6 is the definition, and then that's the function body? Yeah, whatever. This technicalities doesn't matter. I don't think. Yeah, I was right. Operators, initialization, assignment, incrementation, comparison, multiplication. Which we all know already. I hope. Before we can use a particular identifier, we have to program a declaration, which specifies what the identifier is supposed to represent. So yeah, a declaration defines something. Right? Yeah, cool. All identifiers in a program have to be declared, otherwise they will mean nothing, and there will be chaos. It will be chaos. It will be chaos. Several of the identifiers we use are effectively declared in a program: main, argc, argv, a, and I. So we will see where the other identifiers come from. Cool. Okay. Declarations follow a pattern. Each has an identifier and a declaration of certain properties that are associated with the identifier. For example, I is of type size t. Argc is of type int. Main is followed by parentheses and declares a function of type int, and so on and so forth. I'm gonna skip this. So yeah, declarations declare variables, which are named items that allow us to store values. These are best visualized as a kind of box, which may contain something of a particular value. So argc is of type int, so it definitely contains an integer, always. I is of type size t, so it contains something of size t. Yay! Oh my days. This is exhausting to read through. Like, genuinely terribly written book. Like, at least in my opinion. Because the specifics of these... okay, so how should I go for this book? Do I just skip over some of the bits that I presume people know? Should I go for it step by step? Because if we go for it step by step, it's going to take forever until we get to the bit that actually matters. The bit that actually matters is the part where they ask you to do things sorting. That's the part where I want to get to, at least. That is... No, that's challenge number 2. Where's challenge number 1? Challenge number 1, challenge... Oh, I'm just gonna control F. Okay. There we go. So, I want to get to and do challenge 1. So challenge 1 is do a merge sort with recursion and a quick sort with recursion, which brings me back to my first point. Would anyone do this? Like, okay, imagine that you're not new to C, but you've done programming before, and you scroll like a couple pages, and the first thing you see is challenge number 1: do quicksort. This is not reasonable. This is not reasonable. Genuinely, not reasonable to ask you to do this as like the first exercise. It hasn't even introduced switch statements yet. I don't think it's even introduced loops yet. Has it? No, it has. It has introduced loops, but still, it's bad. You're not supposed to do this stuff this quick. Anyways, let's go back. So let's just skip for this quickly. Again, I want to get to the fun part, which is programming. So variables exist, header files exist. So the specifics of predefined features are of minor importance. Information is hidden from you in include files or header files. So yeah, Printf, size t, and x is success are defined in header files. Instead, so we can look them up in the documentation that comes with your platform, or we could do this, which is bad. I'm not going to do that. Identifiers may have several consistent declarations is our next takeaway. So if there are several contradicting declarations, then C will blow up, which is expected. Scope is the part of the platform where an identifier is visible. Lovely. So declarations are bound to the scope which they appear in. So scope is the part of the program which something is relevant in. And then it goes on to describe the scope of a couple other variables, like A is visible inside all of main, I is restricted to only the loop, and so on and so forth. And then this is a lot of stuff, which is annoying. I'm skipping it. Basically, what is scope? It is scope. Declarations specify identifiers, whereas definitions specify objects. Oh, wait. Oh, so I've been referring to it wrong. Okay, so declarations specify what okay, give me a second. So a declaration creates an identifier. So something like int I would be a declaration, whereas I equals 2 would be a definition. Okay, fine, that makes sense. Okay, so now it goes on to talk about arrays, which is the form of the initializer we see here is called designated. A pair of brackets with an integer designates which item of the array is initialized with the corresponding value. Missing elements in initializers default to 0. That's actually useful. For an array of n elements, the first element has index 0, zero-base counting. Each object may have exactly one definition, which we already know from before. Iteration. So I is defined as the loop variable. Then the loop condition specifies how long the for iteration should continue. And then another statement plus I. Okay, this is cool, great enough. I'm gonna skip more and more and more of this. This is the part that they've told us literally you can't read this yet. I think. Yeah. We're skipping that. We'll go back to it later. More stuff to be discussed later. If statements. Okay. Finally, the relevant part. Sanyan. This is awful, by the way. I just want to say this is awful. Like, let's say, oh wait, that does work for a smaller one. I'll guess it doesn't. Oh, it does. Hmm? Yeah. I'm going back to mute. Hello! We have returned. For some reason, when I first start speaking, I feel like the audio volume jumps up a lot. I can see it by this bar. Maybe this is something to do with how I'm doing noise suppression right now. But at the same time, it shouldn't really matter. The limiter, compressor, free band equalizer, gate, suppression, I don't know. Look, all of these sound more like RPG, like not boss names, but like RPG skill names to me, so I'm gonna ignore them and you do some math. Anyways, so I was working on assignment 3 last time, so now we're switching to step because honestly, I got really pissed off at the heroin thing. So now we're doing step, since my computer is also charged up now, so it can work without battery, which is very important. So now we are going to try and get through as many of these assignments as we can. Now, I need to set up my OBS so you all can see what's happening. So step. But now, yeah, my thing is still broken for some reason. Okay, let's see how this works. Ah, found it. Okay, here we go. Okay, now we can see what's going on. So, as a matter of pure curiosity, let's go look at the answer for a hint. For number 3, because I just don't quite understand how you go about the general formula. Okay, but does it improve anything? What a pain. Sure. Okay, let's do some further reading, I guess. Diophantine problems for garden code. Suppose you're asked to solve the equation. You have infinitely many solutions, and you can rearrange to find this. Now, suppose you're asked to find a particular solution, such that both of them are positive, whole numbers, and the sum is as small as possible. You could use trial and error, but this is mathematics, and we like it to be better at mathematics. Oh my god, this was written by a fucking child? A child? Fuck. Okay, wow. I'm unemployed as shit. I'm fucking streaming. I mean, I guess I'm also producing content, but I'm fucking streaming C, like barely starting to learn C on the internet. Jeez, all right. So, how do we find positive whole numbers where the sum of x and y are as small of x and y is as small as possible? One method came out in Alexandra. Mr. and Mrs. Magnus are a happy gnome couple. Unfortunately, foreseeing that they will be unable to keep up with their rising mortgage repayments, they've been forced to move into my back garden. Damn! This was in 2010. I guess, I mean, 2008, there was the crash, but still. What? Damn, the economy is hitting even like gnomes in math problems. Okay, so they've been presented with some problem with building their new home. The total number of bricks must be 177 or planning permission will not be granted. I see. They form roughly the shape of a triangular prism and one wall, namely the garden fence. Okay, one wall is already in place. 2 walls need to be built. So we're rebuilding this. What's the smallest number of bricks they have to buy to comply with the local council yet not waste any money? Zurich. Aha, a German, appears and knows a thing or two about numbers. As his parents discuss it over tea, he writes out, this Zurich individual writes out an equation. So he writes out this equation where total number of bricks is 177, and so this is the plot of land they've acquired, and so therefore it must be 25. It must be 11. Okay, but this doesn't seem difficult. Surely not. This can't be that difficult. Okay. Up with himself. He shows his parents and receives a solemn "That's nice, dear." This person, Emily Woodhouse, is a comedic genius. Much funnier than me. Duly encouraged, Zurich sits and thinks about how to solve this equation. The secret here is that you cannot have half a brick. X and Y must be integers. This rules out that they have the same height, i.e., this isn't a whole number. Fine, fair enough. He's been reading Euclid's... Oh, fuck. Euclid's Elements, and has found out about a nifty trick called Euclid's algorithm, which finds the highest common factor of two numbers. Ooh, Euclid's algorithm. In a later video, we're gonna prove that Euclid's algorithm actually does find the highest common factor. It's like formally proof that the algorithm works. But anyways, I digress. We assume that R1 is larger than R2. Yeah, so this is Euclid's algorithm. It's fairly simple. You just divide one number by the other and you divide R1 by R2, and then divide R2 by R3, R3 being the remainder, and so on and so forth until you get a remainder of 0, where the last non-zero remainder is the highest common factor. It's a very easy algorithm. I'd encourage you to look it up. So, Zurich lets a bunch of numbers and tries to find our lovely highest common factor, which is 1. We could have fucking figured this out by looking at the two numbers, but, you could have figured it out from the fact that 11 is a fucking prime. Alright. Yeah, this is what you'd expect. Then what? He uses the equations he's just generated to write out a true statement equal to 1 that involves 25 and 11. Okay, wait, what the fuck? Okay, I'm gonna start from here then. 25, remainder is 3. 11, remainder is 2. 3, remainder is 1. Yeah, okay. He uses the equations he has just generated to write a true statement equal to 1 that involves 25 and 11. 3 minus 2. Oh, so he substitutes something in. Right, because this is equal to 3, this is equal to 2, so you substitute that in. And after subbing in, you keep them as separate factors. So you separate them out, and then you get this, which is 25, 11 times 3, 11 times 2, plus, I guess, minus 11, and then it becomes 3 times 3. Then he does even more math. Again, doing the same thing here. Substituting in this first equation into here. collects the terms, compare that to the original. And so he multiplies it by. Okay, so what they've done here is they collect the terms, compare that to the original, sub it in, and it multiplies it by 177. And comes up with A, a negative answer, and B, a huge answer. So he wonders how to make y positive without changing the sum from the equation. To make it positive, he needs to add some multiple of 11, say 11n to the right side, to the left-hand side of the equation. To get the equation in the required form, he writes this podcast number. Oh my lord. Okay, this seems really convoluted. I understand why mathematicians hate Diophantine equations now because this is ridiculous. Okay, so what they've done, literally, what they've done is they've got this wrong answer, and now you've got to manipulate this into being the right answer by adding 11n, like some arbitrary 11n, and also minusing that arbitrary 11n. And so he takes the 11n, adds it to 11, which is great enough, but then the bits that he doesn't like, he shoves it into 25. What on earth? And then, since this must be a whole number, he knows that that n must be multiple of 25. So replace it with some, substitute it with some t, which is just a number. So now this person, Zurich, knows that this must be greater than 0. And gets the answer 63. Well and good, till it's not. So 63, what about 63? Oh, and then the answer is 64. Sorry, my brain is fried. The answer is 64 then. Because it has to be slightly larger. Yeah, okay. And then so what he does is he plugs in the numbers and finds a solution. X is 4 and Y is 7. Holy shit! Greeks found this! No, the Alexandrians. I mean, I guess I know why, because otherwise, they didn't have computers to brute force it, and also brute forcing is very mathematical, but still, this is outrageous. So to summarize, first, formulate an equation, apply Euclid's algorithm, and then use the equations that you got from Euclid's algorithm to recursively, iteratively get rid of any factors from the last equation that aren't either 20 or that aren't in the original equation in order to obtain a solution, even if it is an incorrect one. And so once you obtain an incorrect solution, do this. Once you obtain an incorrect solution, add some arbitrary n that is a multiple to it, then minus it again to make the equation correct, just like the original equation. And then do some more fuckery to get to this answer. Okay, this is pretty bad. Okay, linear Diophantine pronunciation. Diophantine. Diophantine. Oh, Diophantine. That sounds alright. I must say how to say Diophantine. I just realized half my screen has been blocked the entire time. Diophantine. Oh, that sounds great. Diophantine. I like Diophantine. Diophantine. Okay, Diophantine equations. Diophantine equations, who dealt with many such problems. If C is a multiple of the greatest common divisor of A and B, an equation of this form has an infinite number of solutions. There are Diophantine equations of higher degrees, for example, this. Okay, sure. So this is just summarization. Okay, so what they've given us is a method to solve linear Diophantine equations. Method to solve linear Diophantine equations with three variables. Jeez, it's free. I don't want to reach ChatGPT, but we'll click onto this link. So, an LDE is an equation, two more integer elements. Z again. Z set of integers. Wait. Oh, 0. Okay, so homogeneous linear Diophantine, shit. Diophantine, shit. Oh, I forgot. 1 second. Shut up, Mr. Music. Nope. Diophantine. Okay. Diophantine. How to solve Diophantine? The hard problem. Okay, so determine the greatest common divisor of A and B. Check that the greatest common divisor divides C. Find a particular solution to AX plus BY equals C by first finding X and Y such that what the fuck? they've really not made any kind of effort to make this not confusing. So, step 3, find a particular solution to ax plus by equals c by first finding x0 and y0 such that ax plus by equals d. Suppose that x equals c divided by d x0 and y equals c divided by d y0. What does it suppose like? Like, suppose that this x0 equals this? That can't be quite correct. Let's look at some examples, right? What the fuck? What the shit is this? Huh? This is not factually correct, Sunyan. Huh? Okay, you can't just spin the fucking solution out of your ass. No, you can't just say a solution is something, something, something. It is not trivial. Look at the fucking mess that they just went through in order to find a Diophantine number, to find a solution. Wait, is this how they do it? Okay. Transforming this into... Okay, so let's say, right, 2x plus 3y equals 9. Is that correct? Yeah, that should be correct. So, how do you solve this? Find x and y such that... Okay, sure, so if x equals 2, y equals 3, arbitrary numbers, then this equals 14. So now we figured out solution for this. And so now suppose that x is CD times 2. And y is CD 3. And why these are are these even technically valid solutions? No, they are not. What? Why is this so infuriating? You know what? I give up. I wasted enough time already. The stream's been going on 3.5 hours. I don't care. It's probably more like 4 by now. Let's just skip this and go do something that is like actually meaningful. I don't care about assignment 2. Mhm. Wait, what is this? Okay, I already know about the monkey problem, so I don't particularly care about this. What is this? Enjoying how to integrate from first principles. What? Oh, wait, by the way, who wrote this? Who wrote this? Is it another child? Oh, it's not a child. Huh. Edited Euler's elements of out. Okay, Euler's thing. But all right, so he's actually a smart person. How to? I'm not watching a 40-minute talk on stream. No, I'm not doing that. Could not care less. No, could care less, but regardless, not relevant. Let's go do assignment 4. Let's go also and remove all of my stupid fucking Diophantine equation bullshit. Never gonna come up in real life, not intellectually curious enough. That's right, you heard it first, I don't give a damn. Right, let's go do some step, I guess. Oh, I already made a copy of this. Okay, so this music's fine. Damn. Okay, so. Oh no. Okay, good. Okay, I'm fine with that. Okay, I'm fine with that. So, warm up. Good. We need a good diagram, nice and big. You may find it helpful to use letters for the sizes of some of the angles. For example, APO equals X. Let A, B, and P be points on the circumference of a circle with center O, such that O lies inside the triangle A, B, P. What sort of triangle is APO? So, we can draw some circle. Actually, no, it just needs to be big, right? Make it big. Nice and big. Whoop. In the middle is some circle O. No, not some circle O, but the middle O. A, B. This is not a repeat. Oh, whatever. Whoop, whoop, whoop. APO. Whoop, whoop. We know the APO. Isosceles. Isosceles. APO. Isosceles. Because of the very obvious example that this is R, this is R. By considering APO and BPO. Oh, this isn't that one, is it? Oh, damn. Oh, no, this is fine. So, ABO being this, some X, is equal to 2 of APB. APB being this being Y. Also, it might be nice to draw this less symmetrically, because that might cause future confusion. So, oh, let's put our P somewhere here. Oh, so we are essentially proving that one circle theorem, where APB is acute. Wait, APB. APB. Oh, this. My bad. My bad, gang. Shit. Okay, no, I need to draw this better. Okay. This is 2y. Oh, come on. Okay, so this is our graph. And this is not 2y. What am I doing? This is our graph. Let me double check. A, B, no, A, O, B. So, actually, move this, it's just that. I'm gonna get made fun of on the internet. Acute means less than 90 degrees, right? I'm pretty sure it does. Yeah. Great. This is our another funky diagram. This is 360 minus x. So we were just applying those familiar rules from a long time ago to figure some of this out. And now I'm stuck. If we can prove that this is 180 minus 2x. And this is likewise because isosceles and some of the thing, whatever. Actually, then I realized I wrote this wrong. It's actually 90 minus, is it? Wait. So it's 180 minus x. Yeah, okay, no, that's correct. So up. I'm having so much trouble with my pen. Oh, god damn it. That. Tongue. There we go. Okay. Not French, by the way. Not French. Just want to make that clear. Let me move this a little bit to the. Yes, we can. My days. Rage bait. Okay, there we go. Okay. This. Nine. Son of a bitch. No! Go away. Okay. Okay, there. 90 minus x divided by 2. There we go. Now we need to figure out why. X equals 2y. Prove this. I feel like the trick here is gonna somehow rest within me drawing a disproportionately high amount of triangles compared to the rest of the step assignments. This is good practice for Cambridge. This is good practice for life. This is suffering. This is truly suffering. I have no idea what's going on here. I have no idea where to start. It's good to get that out. Get to admit it. I'm pretty sure you can draw a line from here to here, though I'm not sure how that helps us at all. I will draw regardless. Now, I suspect we can now formulate some ugly equations. That we can. So, perhaps it's wise to consider a less general case, but at the same time, that doesn't help us, because we wouldn't prove anything using that. This looks so much easier. These are just like quadratics. I didn't do quadratics. I can't fucking do this shit. Actually, no, this is not quadratic. These are all kind of quadratics. What's the equation? It's a cubic. I want to do cubics. I don't want to do triangles. Huh. Oh wait, this is also all. So these are all isosceles triangles. Okay, so let's call this Z. Let's call this K. Yeah, now we can start formulating bitch-ass equations. For example, y equals k plus z. That doesn't help us, but it's nice to have that. $180 minus z, not z, x equals 180 plus 2z plus 2k. X equals 2z plus 2k. Aha! You son of a gun! I got you! La-da! The Trumpian music sounds. Fuck you! Ah, great. Alright, now we got part 2, which is gonna be worse, but still. That was a great moment. Wait, I need to clip that. Let's see. There are like several moments that are slightly more clippable because I've begun streaming longer. And my patience has worn out, so I'm not as, controlled, not as restrained, perhaps. What's this called? Okay, so somewhere. Yep. Go. All right, back to work. Let's see. Prove the same result in the case where O does not lie. We're doing the same diagram. Let's take this shit out. O does not lie inside a triangle, so now we need to slightly modify this. And boom. And this being our lovely P, this being our lovely, as previously established, K. Okay, APB is the cube. This is y. And the rest of this gets confusing fast. Okay, I guess this is technically this, isn't it? It spans the entire region. I guess I'll write this as some anonymous Z. Now we got this being 180 minus v minus k, the minus x, because we've got this funky triangle with z, x, and this. And because of vertically opposite, we can now obtain this. Which means that 180 minus z minus x minus z plus k plus y is equals to, you guessed it, 180, which means these two cancel out. And now you are looking at something like this. Super odd, by the way. Now let's draw some other worse diagrams. For example, 180 minus x. This time we're looking at a, b, and p. So 180 minus x, adding this and this together. Sorry, this and this together. Minus that lovely z. Since this bit, since that bit doesn't count, okay, it doesn't count for our calculation for this specific triangle. And then plus k, and also plus y, equals, you guessed it, 180 again. Which, by the way, exact same equation. So nothing got moved. But we appear to genuinely be at a crossroads. What were z and k equal to last time? Z and k were equal to that. Oh, ooh, that doesn't help. Ooh, yeah. That doesn't help. Ooh. Because last time it was z and k added together, but now it's z minus k, or minus z plus k. Less beautiful, substantially less beautiful. Has anyone clicked on the stream yet? No. making sure that this is correct. O does not lie inside the triangle, and APB is acute. And AOB is less than 180. Okay, fine. So we've drawn the diagram correctly, at the very least. And we need to find some kind of special thing which allows us to progress. Otherwise, we'll go. We're going to try looking at things that isn't just like it adds to 180 degrees. The last time we solved it by utilizing this, right? The fact that these two happen to add together. This time, are there similar coincidences? No. Like, so far as I can tell, no, there are not similar coincidences. Well, I'm not good at geometry, okay? But the only way that you get better at geometry is by doing more math. I see that. I'm not doing math right now. I guess I am. I'm thinking about it, but I'm thinking about doing math, which isn't the same as doing math. I don't feel myself improving right now. Am I improving? Most likely so. I'm gonna miss this one day when I get, famous and popular eventually. Right now, I'm alone. I just mouth off and do whatever I want. No close to solving this though. Um, so maybe I have drawn enough lines yet. Maybe I haven't. I haven't drawn a specific line that's been camouflaged. Yes, okay, so this is some kind of improvement. Although to be well and truly honest, I think I should redraw this. You guys see? No, you can't. Okay, maybe I switch back to this time. Yeah, okay, this works. So, how should I start drawing this? It's gonna be pain. Alright, so this is good. If worst comes to worst, we can just physically measure stuff. What? Is the whole point of a ruler not to... What? It's my ruler fucked. Want to draw lines. Thank you. Oh, there you go. That worked. What's that? Okay, I'm just gonna erase all these. Hello? Oh shit. Oh shit. Life is an endless barrage of bullshit. Oh, lovely. And so when we draw lines from A O B, we need to draw lines from here to here, here to here, and of course, over here. This being labeled as P. So now we've got lovely, lovely, lovely collection of lines. This is X. This is the rapid shot line, so I'm going to redraw it. Maybe I'll draw 4. This could be some Z. This is going to be Y. The Z minus Y. Minus 2Z. Which brings us nowhere closer to our actual goals. But it's funny to write down. Still no closer, by the way, gang. I really want to skip this question, but I can't. My honor demands it. I must solve it. It looks so beautiful. It just looks so algebraic. But no, I must persevere and combat. Do mortal com. Oh fuck, my thing broke. Yep, it definitely broke. 1 second, let me pull one note back up. I'm surprised it took this long break. To be honest, I've been working for like 4 hours. I mean, with on and offs. I took a while to kind of have breakdown, and then I came back. But still, quite endurant. Endurant? Resilient? Mm-hmm. I don't know how to do English. I'm a computer science major. Whee! See, I'm spotting a suspicious lack of triangles here. I could do a quadrilateral, a horrible one, which goes something like this. This shouldn't tell us anything, right? So we're just summing up all of the angles that we've written down. And these two z's cancel out. These two x's cancel out. Wait, oh my god. Wait, these cancel out. So we're left with 2y and 2z. Is that right? Y equals z. That's actually huge. No, it isn't. No, no, it is not. It implies that something's deeply wrong, is what it implies. It is undeniably mathematically true, though. It is quadrilateral. That. Hmm, okay, how odd. Maybe I wrote something wrong. Does sound likely, isn't it? Now there we go. This is not y. This is a z. So yeah, with that addition, we've now proved that 0 is equal to 0. So nothing has been gained. Mm. I feel like my brain cells are dying. Wait, clip that. I'm so fucked. 4 hour for 20. I'm fucked. Mm. Wait, what time is it? Brain is fucking shrinking. Arbitrary constant curve. Standing force for the KKK. So that's 180 minus 180 minus x minus k plus whatever this fucking mess is. C. Let's see. Holy shit, an actual fucking result? That makes sense? Holy fucking shit? Gold alert? Gem alert? Silver alert? Mithril alert? Cobalt alert? Ah, Gem alert? Holy shit. Fucking ass is flowing out of me. Like absolute diarrhea math. Flowing out of me. It speeds unbefore-seen. What is any of this? What? Huh? Now imagine if this made sense, guys. What the fuck? This is one. This is two. So if one. Let's keep poking at it. Comes this. Okay. And Sunyan and what the fuck does this mean? We're trying to prove x equals to y. What does it mean? Genuine. Where do we apply that here? Nope, doesn't make like sense. What the fuck? Whoa. Ooh. No, I've genuinely been working on this for like at least 45 minutes. I don't know anymore, man. What the fuck? This entire thing overall, not just second part, but still. It's an outrageous fucking warm up. It's not a warm up. It's a fucking. It's not a warm up. Is what it is, isn't it? This must be how like. This must be how Americans feel. Like all the time. Damn. I'm clipping that. It's very clippable. We're moving on. I don't give a shit. Preparation! Okay. Oh, I can feel my heart's like having problems right now. If I have a heart attack and die on stream, that just be really sad. So this is the factorization. Shit, yeah, if I had a heart attack and died, that wouldn't be ideal. My phone's out of battery. Oh shit! I haven't checked my messages from anyone in like a day. I should probably end the stream and go do that. Okay, give me a second. Y'all ever eaten rice and then not put enough rice into the cooker and then added water at a slightly more than average amount and the rice comes out all soggy? Yeah, guess what happened? So, back to work, music back online. Is this still on shuffle? It is still on shuffle. Alright. I really like CEO. He's my favorite musical artist. But, without further ado, so, 2i. Factorizing, sketch the graph. So this isn't that hard. We put 4 and -1 here. Our y-intercept is somewhere here. Here being 1.5. And then plug in -3 divided by 2 into our equation. Ends up, of course, being this. Lovely. That's our graph. And hence find the range for which it is below 0. No, above 0. Just simply that. Show that x equals 3 is the root of the equation cubic. We can use the factor theorem here. It's quite trivial. Yeah. So 27, 18, 15 plus 6. 9, 15 plus 6 equals 0. Yep. Find two more integer roots. So now what they're asking is for us to find find the quadratic here, which shouldn't be that hard. So we know that it is -2 because -3 times -2 equals 6. So yeah, therefore this constant has to be -2. But now looking at what this is, so let's say it's some b. Now let's look at how you would obtain a -3x, right? So -3x, it have to be -3 multiplied by b. So -3b plus, actually minus 2x, which we get from 2x, -2x, and x. So remove the x's for obvious reasons, and you get this, which ends up being 3. Which, by the way, clearly wrong, so I've done something horrendously wrong. I've just got no idea what. They never put a fraction in there, I know that for a fact. Genuinely, they'd rather die. Found it. This isn't 3, this is 5. But this is 5. Oop. So if this is b, this is 5, then of course this is trivially 1, which means this doesn't exist. That is our quadratic that we have to factorize. Again, trivial. Yeah. So that is now our answer. Now they've asked us to sketch it, which we shall, in good time. This is -2. This is 1. This is 3. And since it is a quadratic with a positive coefficient of x cubed, it approaches from the bottom, so it's something like this. They've asked us to find the values for which it's below 0, which, again, not that hard. Make sure that it's equals because they've specified equals here, and we move on to part 3, which is quite trivial. I keep calling it trivial because it is trivial. Compare that to, like, this horrendous mess. Compare that to this! It took me 45 minutes and I couldn't make a single dent. I had to just keep substituting random ghost variables with stupid fucking names like Z and K. Who fucking uses Z and K for anything? Z is for, like, sure, complex numbers. K is for constants, not for this. This shouldn't be for variables, okay? This, on the fucking other hand, it's just anyone can learn this. Literally, like, anyone learns this in fucking high school. One up is pissing me off. Right. So they've asked us to factorize another quadratic, which I can literally do just by looking at it. And they've asked us to use that to factorize some other number. Oh wait, no, I've done it wrong. Oh, okay. Oopsie doopsie. It's actually this. So it is in fact this. Equals 0, according to the next part, which show that if it is equal to 0, then the point lies on 1 or 2 straight lines. Okay. So if xy equals 0, then x equals y. If if this equals 0, then x equals to y. So these are the 2 straight lines. On a sketch the regions where it is below 0. So let's pick some various points. Pick one. Oh wait, sorry, I forgot to mention we're doing IV now. So on a sketch shade regions where this is below or equal to 0. So we are going to draw some certain. Well, first we're going to label this properly. Then we're going to do some points. So this is a point that is in this region. We know that. Let's see. So this is a point that's going to be in this region. Now we need a point that's going to be in this region. Let's do 2, 3, 2. Does that work? No, let's do 2, 3. Which would put us somewhere here, I believe. Yes. Great. So now that we have those points, let's begin mapping them out, right? So our equation is this for this mess. So for the first one, 1, 3, 1, 9, 18. So this all is not shaded because this is positive. Now I should indicate that more clearly. I shouldn't. Now let's go look at the second point, which is 2, 3. Again, sub it in. Still positive. Finally, 2, 1. Which is just perfectly 0. Which is really bad, by the way. Because it shouldn't be. Means that I have done something very wrong. That I have. Because this, I'm ashamed to admit, is the wrong graph. It's actually this. That was a lucky spot. And by spot, I mean guess. Oy. So actually, something that will make it clearer is this. Now you can see why it's a bit steeper, because actually, for every increase in y by 1, x actually only increases by half. So yeah, it's actually this. So now this is all negative, and we need to find some newer graphs. So let's do, for example, 3, 2, maybe 3, 1. Yeah, this does seem appropriate. Now let's ignore all of these and go on and do some more maths. I love plugging in numbers. I love not thinking. So this is negative, which means that this is not negative. And 3, 1. Which means that only this is negative. Yay. Found it. Are we looking for... Oh, we're also looking for that. Now I am pretty sure that the negative of this being, I believe... Is it -3, -2? So it'd be somewhere like here. I believe that to be correct. Let's plug it in. So it becomes 9 minus 3 plus 2. Yeah, so this is literally the exact same equation. which turns out to be -1, so this is in fact negative. So yeah. Now let's move on to the step question. Find the real values of x for which this is below 0, which is the exact same question. X -1 is a vector because if we plug in f equals 1, then it becomes 1 minus 4 minus 1 minus 4, which is 0. The reason you can deduce this is just guesswork. You can just plug in 1, -1, enter the factor theorem, and get the correct answer. Usually that's the case for these, at least. So now you just do a bit of the same quadratic mystery. So this has no coefficient because x times x squared is x cubed, which is what we have here. Then you got -4 as our coefficient, and then you have -4. You got -4 minus -b equals to -1. Means that b -3. So now we can factorize the quadratic by doing -4, 1. So now our answer is this. So now you're asking us to find the real values for which it's bigger. So again, we draw a lovely little graph. Here, here, here. Ta-da. Bigger, so done. Great. So now, find the three lines in the xy plane on which x cubed minus numbers, numbers, numbers. This is the same thing, I believe. So yeah, you can translate this into three different equations. One is fairly straightforward. Another is really straightforward. And one is simply extremely steep. Positive, positive, what a pain. Right, so this is just a pain of a question. Right, so it won't be hard. We just have to pick up some certain points to do some calculating on. Let's pick 0, 2. Oh, sorry. It's 2, 0. One, 2 existing here. Negative, sorry. 1, 2 positive this time. And some value sitting here. 3, 2 sounds appropriate. 3, 2 sounds appropriate. Now let's go about the fun business of plugging in numbers. Wow, exciting. Negative. So this is all negative. That is surprisingly also negative. This is a question mark. Could be positive. Of course, there is a chance. That's actually positive 8. But regardless, it doesn't change the outcome that this is in fact negative. Now I suppose we'll do -1, -2. Why not? Why not? 10 out of 10. Negative, yeah, just making sure the negative signs don't fuck with anything. So now we've got this and we've got this. I suppose doubting myself was a bit of a foolish decision, but I did it already, so what's to be said? Which is obviously positive. Finally, we have 3, 2. Funnily enough, that spells negative. Now, how sure are we of this? Quite sure of the math is infinity, right? Means that by sheer correspondence, all of this is negative. That means there's only a top bit, which is not negative, which I genuinely very much doubt to be correct. So we will go look at answers. First. Uh-huh. So we've done 2 things wrong. There are 6 regions. Suppose there are, if you can count. Ah, I see. These two are separate regions, so you have to do them both. Okay, so now I'm just confused, right? Just outright confused. I feel like I'm bad at math, but I'm not that bad at math. Maybe I am, but what's gone wrong here? Let's clean this up. Those points plus also 1 out of the shear, which I suppose was justified. Like I want to. Wait, you just completely misread the assignment. Larger than 0. Ah, larger than 0. So I have misread the assignment. So actually, that would have been my answer, which would still have been horrendously wrong. Oh, bloody hell, this is all 0. This would have been positive. We would have rendered it like this. Also, I seem to have literally removed one of my lines, so that. Okay, so some full combination for arithmetic and baseless assumptions. What can we? Yeah, fucking makes sense. Because I thought it was like this, and they basically did carry over. Like if this side was wrong, then this side would also be wrong, and vice versa. Because I thought they'd flip like perfectly, and it's evidently not the case. It's shown here. I got the rest of them right. Oh wait, there's also our last last. I have 4 double-sided cards in front of me. E, 6, Q, and 7. You claim if there is an even number on one side of the card, there is a value on another. If even, vowel. However, not if vowel then even. Turn over 6 only. It. No, actually, you also have to turn over E, don't you? Because it doesn't specify if it's the front or back side of the card. Actually, you might have to turn over all of them. There are a lot of valid answers. Alright, let's think about this. If there is an even number on one side of the card, there's a vowel on the other. Let's think about it just numbers, right? We have a set of A and B. If A is 1, B is 2. B is 2. Is A 1? That's the question we're asking here. Then B is 2. No, that's not correct. No, that's not correct because it specifies that it's A and it's B. Whereas we right now we aren't specifying anything. We're just specifying one of the sides. So it'd be more like if one number is 1, then the other number is 2. One number is 1. Is the other number 2? Obviously yes. Right? Yes. Yeah, so the answer is turn over all of them. Actually, no, I think we could write claim is false. Yeah. This is fun. So I have two identical but non-uniform ropes. I know if I light one end of iron rope, it will burn for exactly 1 hour. This is a BIO question. I recognize you, son of a bitch. It's you. It's you. I'll have you. Those who know. I recognize you, you son of a bitch. You bitch. I know you. I know you. I've seen you before. Right? You think you can trick me again? Yeah? Yeah? You and your tricks. Okay, so in all seriousness, let's do this, right? So I've got two ropes. And now if I light one end of iron rope. Oh, that's easy. Uh, light three ends when one is burnt. Like the last end. When that is burnt, 45 men have elapsed. Easy. Okay. This was uncharacteristic of me. I don't usually make arithmetic mistakes when I'm really focused. So I really need to, or when I'm not trying to go fast and I'm not focused. So I was focused. I just wasn't trying to go fast. So in the future, I should be careful with this. When do questions, and I also shouldn't make too many assumptions, I guess. Yeah. So that's a tricky little question. Got me out there. Fair enough. Anyways, this question. What's our time looking at right now? We're at 5 hours and 30 minutes. Oh, chestnut indeed. Right. Is our original diagram correct? Is the first question. I always worry about my diagram being incorrect. So let's go back. We're going back to this question, by the way, in case you haven't noticed, in case you haven't picked up on that. How much battery do we have left? 18%, not a lot. So what do we have here? We have an advanced problem solving module. Not excellent. Which doesn't exist. Good. I hate doing math. Got assignment 5 here. Oh lord. Alright. I'm just gonna make sure acute means what I think it means. Yeah, less than 90 degrees. Wait. Wait a minute. K equals Z because of isosceles. Because these two are equivalent. Hmm. Yeah. I hope that's plot relevant. Really do. That's it, I guess. What a horrible question. Just Genuinely. Wait, 2 assignments and written a bit of code. It took me 5 hours. I don't even know what to say. Fuck. Should be quicker. You know. Still no viewers, by the way, so. Mr. Rate Discovery. I got more work done than I usually do. Just, yeah. Face to wash, I've got. Face to wash, I've got a shower to hit. I haven't done any exercise yet today. Overall, today was fun. At least today was workful. I'm being melancholy right now. But I guess I've learned it. Okay, I want to do some clips of the stream because I feel like what is it? I want at least one view. One viewer is all I ask for. Eventually, we'll hit 10 million, but one view. So I'll end the stream early, a little early, and I'll go try and make some YouTube clips. I'll wash my dishes, take a shower, and wake up early. Get ready, punch in tomorrow. Hopefully tomorrow we can finish off more of these assignments. Thanks everyone for showing up. See you next time.